Okay, here are some pretty cool questions. That's code for hard. They're sort of hard, but at the same time, they're so doable. If grade 9 students, you can do these questions, but even though you can do them in grade 9, grade 11, they're still challenging if you don't look at them the right way. So just to test you out, why don't you see if you can press pause, see if you can simplify that, and then come back and see if you get the right answer. Okay, let's expand that. So that's going to be x to the, we're going to multiply that, so it's going to be AB plus B multiplied by x to the A plus B. Let's expand this thing here. That's x going to be to the AB plus B times x to the 2b. When we multiply like bases, we add our powers. X to the AB plus B plus B. Oops. On. And we have we're multiplying like bases, so we add our powers. AB plus 2B, which is AB plus 2B. Oh, I stuffed up in that, this thing here. Let me go back there. Let me show you. That should be AB plus A. I wrote it as AB. So that means when I add that and that, I get A plus A. And I'm sure you can see it. My powers are the same, so the number on the top and the bottom are actually the same. So that just cancels all out to 1. Something divided by itself is 1. Okay, press pause and do it. See that minus? That's a real problem. We can't apply index laws with minuses and pluses in there. It doesn't work. We're not multiplying or dividing like bases. So I'm going to look at that. Just as x cubed times x squared is x to the 3 plus 2, I can take x to the 3 plus 2 and go backwards. So this is 5 to the n plus 1, which is going to be 5 to the n times 5 to the 1, and 5 to the 1 is just 5. Same thing here. That is 5 to the n times 5 to the 1 plus 5 to the n. I'm going to write that differently. 5 to the n minus 5 times 5 to the n. 5 times 5 to the n plus. There's lots of 5 to the n's and 5's in there. Let me highlight the top. You can see there that I've got something common between those top two terms, and the common thing is 5 to the n. So when I factor that out, I'm left with 1 minus 5. On the bottom, I've got 5 to the n common to the two terms, so let's say 5 to the n outside of 5 plus 1. Guess what? The 5 to the n cancel. 1 minus 5 is minus 4. 5 plus 1 is 6. There we go, all on one page. Similar. Press pause and see if you can do that one. Just like the other one, I'm going to make that 3 to the n plus 3 times 3 to the n. This one will be 3 to the n plus, minus 1. What's that? How about 3 to the n minus 1 is the same as 3 to the n times 3 to the minus 1. Because that's n plus negative 1. 3 to the minus 1 is 1 on 3. So it's sort of exactly the same as the last one, but also a lot harder, because that is 1/3 times 3 to the n. Because this is 3 to the minus 1. Again, we've got 3 to the n common. So 3 to the n, 1 plus 3 on 3 to the n, 1 plus 1/3. The 3 to the n's cancel. 4 on 3, which is 3. Are you okay with that? 4 divided by 4/3 is 4 times 3/4. 1 times 3 is 3. Yes, fractions core skills. Love them. Is there another one? How many more we got? Gosh, 2 more. Hang in there. What are we going to do? Simplify, simplify, simplify. Let's get rid of that negative 4. When that negative 4 goes into that bracket, it's going to put that to the bottom and that to the top. So it's going to be p to the x minus 1 on p to the x plus 1, because they've flipped, and then it won't be a negative power. P to the 8x plus 8 on p to the 8x, and p to the squared on 1. Let's take that 4 in. Oh, no, I won't. Yeah, let's simplify this. It's going to be x minus 1 minus x plus 1 as a power of p, because I'm dividing like bases. So it's going to be x minus 1 minus x minus 1, because that minus distributes. So all of that is going to go to minus 2 p to the minus 2 times okay, here we are dividing like bases. So we subtract, so it's 8x plus 8 minus 8x. This p goes to the bottom, and clearly they cancel. So the answer is just p to the 8. How'd you go? Did you get that one right? P to the 8. Last one, promise. No. We've got 2 more. Goodness. Okay. That's a power of 6. Let's just see how we go. You can see we've got the 6. So 6 to the 2m. See, the power is both minus m. So let's just go xy squared is x squared y squared. We're used to putting everything in that bracket to the power, aren't we? It does also mean that if I start like that, then I can go back to there. And that's what this is. I've got the same power. So I can write that's 2 times 3 to the minus m. Yep, can you see that? I'm going to rub that out. And I've got another one there. So that's going to be 3 times 2 to the 2m, which is 6 to the minus m times 6 to the 2m times 6 to the 2m. I've got like bases of 6 now. So it's minus m plus 2m, which is 6 to the 3m. Easy, simple, but challenging all at the same time. This is a solve for x, so this is actually an equation with an equal sign. So different technique involved here, but we can see that thing there is very similar to what we had before. Because 4 to the minus 1 is a quarter. Yep. And that equals 48. We're still not out because I don't know whether you can see that. I'll write it. How about it's a minus a quarter of a. So that's a like term. What's 1a minus a quarter of a? Well, that's got to be 3/4 of a. So it's going to be 3/4 of 4 to the x equals 48. Let's. I don't want to multiply that by. So let's just go. Let's divide by 3 first. So that's got to be 3 watts of 48. 3 16s of 48. There we go. That took me a while. So that's going to be. And then multiply by the 4. And we're going 4 to what power is 64? That's like an indicial equation. 4 to the x. Well, 64. 4 4s are 16. 4 16. So it's going to be 4 4s are 6. Yep, that's right. Therefore, x equals 3. So that's not a simplify. That's a solve for x. Sweet. Enjoyed that one. How'd you go?